Hello YouTube, this is my third video that I'm making in my module on sketching trig functions, and we're going to again specifically explore the graphs of y equals a times sine of bx and a times cosine of bx, where we've been messing around with the b value. In the previous video we determined that the b value actually is just really telling us how many cycles the graph goes through in a normal 2 pi period, but in other words b is a period alterer of our graph. Okay, and so what we could say is this. If b represents the number of cycles it goes through in a normal 2 pi period, then we say the period of the graph of these two graphs is always equal to the normal 2 pi period, 2 pi, split up b ways. That would give us how long just one of those cycles would be. Okay, so we're going to use this fact that the period of these two graphs is always 2 pi over b, and the fact that a is the amplitude to kind of explore how to sketch these things. So we say in example 3 here, let's use what we know about the graphs of y equals a cosine of bx to graph one complete cycle of the graph of cosine 1/2 x. Okay, I do want to point this out. Before you start this, you should always write down what you know. And in this instance, we know that the a value up front here, this is 1. Okay, and the b value on the inside there is 1/2. Okay, so the two things we're going to find before we sketch this are always amplitude, if it exists, and period. Okay, so we'd say first of all, amplitude. The amplitude of this graph is the absolute value of the a value. So we say the absolute value of 1, which is 1. So this graph has an amplitude of 1. And in terms of the period, we say the period is always 2 pi, or the normal period, over b. So we say 2 pi over b. In this case, that's 2 pi over 1/2. Okay. When you divide by a fraction, though, recall that you're always multiplying by the reciprocal. So this is 2 pi times 2 over 1. So we'd say the period of this graph would be 4 pi. It would go through half of a cycle in a normal 2 pi period. So it would go through a full cycle in twice that length, or 4 pi. So to sketch this graph, here's what we often do. Is we go out one period past 0. We haven't horizontally translated anything yet. So we'd say, in this case, 4 pi is the length of its period. Just as normal, we're going to cut this length in half. So we'd label this. We'd say, well, half of 4 pi is 2 pi. And we'll cut those lengths in half. Now, the amplitude of this graph being 1, we'll go 1 above the x-axis and 1 below the x-axis. Now we just need to know the normal shape of the cosine graph. And we know that the cosine graph starts up in the air. At 0, it starts up at its maximum. A fourth of the way through its cycle goes down to the ground level. Half of the way through its cycle down on its minimum. 3/4 of the way through its cycle back up to the ground level. And then it proceeds to go back up to the top here. So we'd say this is our cosine curve in this case. So it is as easy as that. Just identify a and b, and then from there we can identify the amplitude. And then the period of the graph, like we said, the period is always 2 pi over b in the case of sine and cosine. Or in general, we say the normal period of the graph, which of sine and cosine is 2 pi, split b ways. And in this case, b was 1/2. So I've listed these notes here, by the way. You'll want to know this like off the top of your head. But we say for sine and cosine, for graphs of a sine bx and a cosine bx, we say the amplitude is always absolute value of a, again. Then we say the period is the normal period, 2 pi, split b ways. So if that's the case, here's what I'd like to do before we kind of proceed. I said for the following equations here, let's just identify the amplitude and the period. So I just wanted to show how easy this can be before we do a problem. We say a and b. So in this case, we say our a value looks to be 2. We say the b value also looks to be 2. So in terms of the amplitude, we just say amplitude of this graph is the absolute value of 2 is 2. We say the period of this graph. Okay, so how long would it take this graph to go through one full cycle? We say, well, the period would be 2 pi over b. In this case, we have a b value of 2, which means that the period of this graph is 1/2. So we'd have an amplitude of 2 and a period of 1/2. On this next one here, we say, well, a looks to me that the a value is 1/4. The b value is 5. So we say the amplitude of this graph, the amplitude would be equal to the absolute value of 1/4, which is itself 1/4. Is a fourth. Okay, so fourth. That's very ugly looking 1/4. Sorry, 1/4 period. Okay, so the period, this b value being 5 just means that it's going to go through 5 complete cycles in a normal 2 pi period. So how long would that be just in one complete cycle? So we'd say we'll take the normal 2 pi, in which it did 5 cycles, and split it up 5 ways, and that would tell us the length of one period. Okay, a one cycle. So one cycle would take 1/5 of the 2 pi, or 2 pi fifths. Coming down here to sine, we see that we get some negative a values for the first time, but we say in this instance, we say the a value is -4. The b value here looks to be pi. So to identify the amplitude, we say the amplitude is the absolute value of, let me go ahead and draw this in, absolute value of 4, which is 4. Recall that amplitude is always positive. We say the period of this graph then would be the normal period, which of sine, it normally has a period of 2 pi to complete one cycle. We'll split that up by b. So we say 2 pi over pi. We say this graph would actually have a period of 2. And on this last example here, we say the a value looks to be a negative 1 out front. The b value in here looks to be 1/3. So we say 1/3. So as far as the amplitude goes, remember amplitude is always positive. So we say the absolute value of -1, which is 1. And then we say the period. The period, we just take the normal period of this graph. In this case, we say the normal period of cosine is 2 pi. Say 2 pi, we'll split it up b ways. So in this case, it's just another example where we're doing it with a fraction. We say 2 pi divided by 1/3, that's the same as 2 pi times the reciprocal, which is 3 wholes. So this would be 6 pi. In other words, it would only go through a third of a cycle in a normal 2 pi period. So it would take it the other 2/3 of the graph would take another 2 pi and another 2 pi. It would take a total of 6 pi to go through one complete cycle. So knowing what we know about this now, what I want to do is I want to graph the graph of y equals 2 sine 2x. Okay, so what we're going to do here is we're going to identify the amplitude and the period, just as we've done, and then identify the domain and range of this graph. So here we go. We say, first of all, the a value in this instance is 2. The b value in this instance looks to be also 2. So we say the amplitude of this graph. The amplitude is the absolute value of 2 is equal to 2. And then we say the period of this graph. Well, what's the normal period of a sine curve? Well, 2 pi. That's how long it usually takes it to go through a full cycle. We'll split that up 2 ways. So since it's going through 2 cycles in a normal 2 pi period, that means that it would only take it pi to go through 1 complete cycle. So knowing what we know about the amplitude and the period, to sketch this now, here's the way this works. Every time we go out 1 full period past 0. So in this case, period is pi. We say, okay, we'll split this in half. Half a pi, that's pi halves. Pi halves, and we'll split those in half. So we'll quarter up the period here. And then we say, okay, well, the a value being 2, that means the amplitude's 2. We'll go 2 above the x-axis and 2 below the x-axis. Now it's just a matter of, do you know what the regular or parent function of sine of x looks like? Yeah, we know at 0, or at the beginning of its period, it starts on the ground level, proceeds up to its maximum, half of the way through its cycle, comes back down to ground level, goes down to its minimum, and then goes back up to ground level. So you can see here that the amplitude of this graph is 2, and if we were to extend this graph, just to show you here, if we were to extend it out to 2 pi, which we could do, we could say this is 3 pi halves, if we did this, that you could see that this graph would actually go through 2 complete cycles in a normal 2 pi period. That's why we say it only took just pi to go through 1 complete cycle here. So we say the period of this graph equals just a pi because it went through 2 cycles in a normal 2 pi period. Cheers. One more thing, we need to identify the domain and range of this graph. Very, very quickly, we say the domain. Just recall that the domain of any sine and cosine graph is all reals. All reals because we could take the sine or cosine of any x value. This graph goes left and right forever and ever. As far as the range goes, we say the range, it was always stuck between these 2 y values right here, -2 and 2. So we say the range. The range, one way to write this would be that the y values were bounded between -2 and 2. They were stuck between them. Cheers again.